Welcome back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you through diagonalization of a matrix. And don't forget, we have been doing a lot of work on matrix, linear algebra 2, and so on and so forth. Don't forget to subscribe to our channel, Further Solutions Academy. And share among your friends is very important. And also, if you have any problem, just try to, to contact us on our email. We are already available. We are always there. Now, on this video, I'll be working on this part of a matrix, which is known as diagonalization of a matrix. Don't forget to share. At the end of it, by the end of this video, you will understand how to diagonalize 2 by 2 matrix. 2 by 2 matrix. Now, at the beginning, let me just try to explain what is called diagonalization. By now, before you can do that in mathematics or in matrix, you must understand, number 1, how to generate characteristics equation. Number 2, eigenvalue and eigenvector. And secondly, you know how to do the inverse of a given matrix. Those are the things that is known as what? Diagonalization. Now, if I can tell you, my diagonalization equals to, which is diagonalization of any given matrix, it is equals to m, let me put this an eigen, and what? M, that is inverse of a given matrix. Inverse of a given matrix, this is a given matrix, this is a given matrix, the matrix given from the question. This is the eigenvalues. Eigenvectors. Now, you know that it's 2 by 2 matrix. Now, if it is 2 by 2 matrix, it means you have two vectors, which is x1 and x2, like that. And this one, you have what is called inverse of a given matrix. Multiplying them together, you will have your what? Diagonalization. I think I have a problem here. Let me try to show that for better explanation. For instance, I have this given matrix. Let m equals to 7 minus and 1. That is my m. Now I want to diagonalize the given. Diagonalize the given matrix, which is my m. My given matrix is m. Now, how do I solve this problem? Let's try to solve it together. Don't forget, what I'm working towards is my diagonalization equals to my m, and my what? Some people use p. Anyhow you want to do it. For my own, I will put my e there. Now, my m is this. I have no problem with my m. What I'm having problem with is the what? Now, I will now generate my eigenvalues now. I want to generate my what? Eigenvalue. How do I generate my eigenvalue? Now, eigenvalues. Now, how do I generate my eigenvalues? The first thing I will do is that, by now you should know how to generate your characteristics equation. Now, my characteristics equation will be lambda squared, and the trace of this minus, what is the trace? This minus this, I'll be having this plus this will give me 8 lambda. Now, plus, now the determinant of this times this minus this times this. Now, this one will give me 7, that will be 15. That will be 15, yes. That will be plus 15 equals to 0. Now, please, I've done this in our previous video, how to generate characteristics equation. If it is 3 by 3 matrix, I think we will have to work on that later. That is going to be later work. That should not be a problem. Let's try to manipulate, to utilize the space very well. Now, I have this and I've done that. The next thing I need to do, let me generate my eigenvalue. My eigenvalue, it means I want to generate the what? The factorize this thing. I want to factorize it. It means I'll be talking about what we multiply to give me 15, and the same number will be added, it will give me 8. What are the number? I think I'll be talking about it means lambda equals to 3, lambda equals to 5. Sorry, This is advanced mathematics. I'm not here to come and teach you quadratic equation. I try to understand that lambda should be equals to 3 and lambda equals to what? 5. If you have problem with that, you can private chat, there won't be any problem. Now, that is my lambda. My lambda equals to 3, my lambda equals to 5. I will just say when my lambda equals to 3. Now, when my lambda is equals to 3, it means this is what? Cholesteritis equation. Cholesteritis equation. Now, why this is known as what? This is called eigenvalues. That is eigenvalues. Take note of that. Now, from my eigenvalues, I want to generate my what? Eigenvector. Now, my eigenvector for 3, when lambda equals to 3, it means I will come here 7 minus 3 and 2 and minus 4, 1 minus 3. Now, which is my x1, x2 equals to what? Is 0. Equals to 0. Now, that is, I think, please, for information, at this point, you must to understand the previous video very well before you can talk about diagonalization. It means before you can watch this video, kindly try as much as possible to watch the video before now. Eigenvector, example on eigenvector, definition of introduction to eigenvector, characteristics equation. They are all explained there because I'm just trying to continue from where I stopped, which is on characteristics, diagonalization of a vector, of a matrix. Now, I have this. Since I have this, I can now say that what? Here minus this, I'll be having 5. Here will be, this will be 4. And here will be 2. Here will be minus 4. And here will be minus 2. And I'll be having x1, x2, and equals to 0. And I can put it 0. There's no any problem there. Now, if I have this thing, what do I need to do now? I just need to do something for myself. I will, the matrix become 2, minus 4, and 0. Now, that is what is called augment matrix. The augment matrix, x1, x2. Now, I want to use my rule reduction. My rule reduction, I can say that my R1 equals to 1 all over 4 R1, and my R2 can be equals to 1 all over 4 R2. Now, which I'm trying to reduce, reduction, it means I'll be having 1 all over 2, and 0, here will be minus 1, here will be minus 1 all over 2, and here will be 0. Now, I want to reduce. It means my R2 will be equals to R2 plus R1. R2 plus R1. It means I'll be having 1 all over 2 is 0. This one becomes 0, is 0, and is 0, which is mine. Now, for your information, at this point, my x1 plus 1 all over 2 s2 will be equals to 0. Now, since I have this, what I need to do now is that since I have this, I can now continue by having my x1, 2x1 plus x2 equals to 0. 2x1 equals to minus x2. Now, for what I'm having now, I can now say by what? My x1 equals to minus 1. My x2 equals to what? Equals to 2. Now, from what I'm having now, I can now say that what? My x1, x2 will be equals to minus 1, 2. I can also say that it also implies that 1 minus 2. Anyhow, please, at this point, I want to put x here. Why? Because of what? There is a problem here. There's a problem here. If I'm giving you a question that you are handing up like this, if to me, you try to what? Diagonalize. I mean, you try to normalize. Sorry, let me use the word normalize. You have to try to normalize, but let me just leave it like this. It's okay like this. Let's present it like this. Now, the next thing I need to do when lambda equals to 5, when my lambda equals to 5, it means my eigenvalue 1, I mean eigenvector 1 will be equals to what? 1 minus 2. There is no any problem. Now, I want to work on that, the other part, which I will be talking about. I'll be having, when my lambda equals to, it means 5 minus 2, and 2, and minus 4, 1 minus what? 5, which is, I'll be having x1, x2, which is going to be 0, 0, 0. Now, can we continue? This one will what? 2, and here will be 2, here will be minus 4, here will be minus 4, and I'll be having x1, x2, and equals to 0, 0. Now, I can do the same thing. I want to reduce. It means by so doing this, by now, I think you should be able to understand. I'm not here, you should be able to understand this by having 1, 1. Take note of that. I'll be having 1, 1, which is going to be minus, minus. Let me put 0, 0. There is no any magic. Sorry, I just need to, I divide row 1 by 2. I divide row 2 by what? By 4, which is, I have that. Now, since I have that, I can now say that my row 2 can be equals to row 2 plus row 1, which you know the implication, which I will be having 1, 1, and 0. This is going to be 0, 0, 0. That is what we're going to have there. Now, since I have that, I think the problem is half solved. Okay, permit me to rub this part. Now, that will tell us that my x1 plus x2 equals to what? Is 0. My x1 equals to minus x2. Now, my x1 equals to minus 1. My x2 equals to what? 1. Now, back to what we are trying to do. It means my eigenvalue 2, let me call it 2, will be equals to x1, x2, which will be equals to x bracket of, please take note of this. Why am I putting x bracket? Because we are having what? We have what is called independent and non-independent. I think I'm not going to talk about that. Later we'll talk about that. Now, I'll be having minus 1 and 1. Anyhow you want it. Or I can also say it 1 minus 1. I think anyone I want to do. Yeah, don't forget your x here. Now, it means my eigenvalue 1 equals to 1 minus 2. My eigenvalue 2 equals to what? 1 minus 1. Now, that is very, very correct. Now, for the next thing we need to do is that we need to generate our what? My n inverse. My n inverse. My n inverse. Now, my n inverse is very simple. You can use transformation method, is allowed. But me, I will be very comfortable with normal method that is very, very common. Where is that question? I've even lost the question somewhere. Okay, the question is, my m is equals to, sorry, I have to put down 7, 2, minus 4, 1. Okay, that is my n. My n inverse, sorry, I won't be able to use, what's the transformation method because I don't want to go on the long journey. Now, this and this, I'll be having 15, yes, times this, which is plus, yes, it will be 15, 1 all over 15. Now, switch this and switch this, I mean 1, 7, here will be plus 4 and minus 2. For your information, that is my m inverse. It means indirectly my m inverse will be equals to 1 all over 15 and minus 2 all over 15 and 4 all over 15 and 7 all over 15. That is my m inverse. Now, what am I diagonal? My diagonalization is not equals to my M, E, and what? M inverse. Inverse of N. Now, what is my E? My E is equals to, some people use P. Don't be confused. You can use anything, but my own, I'm comfortable with my E, which I would now say that what? Eigen of 1, eigen of what? 2, which it will be equals to, what is my eigen of 1? I have 1 minus 2. My eigen of 2 is 1 minus 1. Now, it means my diagonalize, it will be equals to what? My M, E, my M inverse. Now, what is my M? My M is a given question, which is 2 minus 4, 1. 1. My, what is the? My E, which is my E, is equals to 1, 1, minus 2, minus 1. And my M inverse, my M inverse is 1 all over 15, minus 2 all over 15. And lastly, I have 4 all over 15, and 7 all over what? 15. That is all. Can you see? It means this is my what? Diagonalization of what? Of N. Now, there's no any problem here. You know how to multiply by now. What I will just do is that you can multiply this with this, which you know all those things. I think this multiplied by this plus this multiplied by this, which will be what? 7 minus 4, it will be 3. I'll be having 3. This multiplied by this multiplied by, that will be what? 5. That will be 5. That will be 7 minus 2. I'll be having 5. And this one, minus 4, minus, that will be minus 6. And minus 4, minus 1, that will be minus 5. It means it will be equals to what? 1 all over 5, minus 2 all over what? 5, and 4 all over 5, and 7 all over what? 5. Can you see? Can you see? That is, it means I'm working on my diagonalization. Now, I can also do the same thing, and I think let me finish it. So let me do outbound. It's good to finish the work. Let me just finish what I started. Okay, so that you won't say that, Mr. Lele, you are so lazy. I don't want that I don't want that comment on the channel. Now, the last part is that you can now say that my D equals to, I have 3, 5, minus 6, minus 5. Hope I'm not making a mistake. No. And 1 all over 15. I have minus 2 all over 15. And I have 4 all over 15. And 7 all over 15. Now, how do I multiply this? Is also very simple. This multiplied by this plus this multiplied by this. It means I'll be having 1 all over 5. 1 all over 5 plus that'll be 20 all over. 20 all over. Now I think I'll be having 1 over 5, that'll be 4 all over 3 plus 4 all over 3. 4 all over 3, which I'll be having 15. 15, that'll be 3 plus 20, that'll be 3 plus 20. 3 plus 20, that'll be 23. 23 all over 15. It means 23 all over 15. It means it will be 23 all over 15. The next thing is this times, this times this, that is minus 2 all over 5, and this times this, it will be plus 7 all over 3, which is, I'll be having 4, that'll be 6 minus 6 plus 35, that'll be 29. That'll be 29. I'll be having 29 all over 15. 29 all over 15. The next thing, I'll be having 6 times this, which is going to be what? 6 multiplied by 1 all over 5, 15. 3 here with 2, 3 here is 5. 3 here, that is 5. It means I'll be having 2, 3 here, 3 in 6, 2, 3 in 5, okay. That'll be 2 all over 5. Okay, and this multiplied by this, it means I'll be having minus, which is minus 4 all over 3. Sorry, 4 all over 3. This is minus. This is minus also. It means I'll be having 15 times 3. That'll be 6. 20. That'll be 26 all over 15. That'll be 26. Yes, minus 26. 6 and 20, which is going to be what? Minus 26 all over 15. Can 3 divide 3 here 13? 3 can divide 26. No, 3 cannot divide it. Now, which will be what? Minus 26 all over 15. And lastly, the last part of it, this times this, that will be what? That will be 2, which I'll be having 2. 6 multiplied by minus 2 all over 15, which is 3 here 2, 3 here 5, which is going to be that will be 4 all over 5, plus this times this, that will be minus 7 all over 3, which is going to be 15. That will be 12 minus 35, which I'll be having 15 here. Now this minus this, that will be 25, 23. That will be 23 minus 23 all over 15. That is all about that. Minus 23 all over 15. Now, can you see? I'm just trying to do multiplication of a matrix. Now, it means my diagonalization, it will be M inverse will be equals to what? Will be equals to 23, 15, all over 15, 29, all over 15, and minus 20, all over 15, and also minus 23, all over 15, which I can also write it this way. My diagonalization can be also equals to 1 all over 15 bracket of 23, 29, 26 minus, and also minus 23. That is my final answer. Okay, in the next video, I'll be working on 3 by 3 diagonalization. You can see it's very, very simple. It's very, very simple. Don't forget you are home with Further Solutions Academy. Once again, thanks for watching.